Hey there YouTube, this is SJM4306, and in today's mailbox unboxing slash review is caution lithium-ion battery, do not load or transport package if damaged. For more information call yada yada. No, so basically I was clued in on another send-in for review, and I believe I know what this is, so let's just give it a quick tear open and see exactly what we got here. And yes, it is exactly what I thought it was. This is awesome. Okay, so yeah, this is from Banggood.com, and I received an email about a week ago. This was actually very quick, and they'd asked me, "Is there anything that you'd like to review?" And I said, "Oh boy, yes there is." And so they had sent me over this. It's a DS212 oscilloscope, US 29. What? No, okay, yeah, it was like a hundred and something, I believe. I'll post links down below. And so yeah, basically they had very generously sent me a portable pocket oscilloscope, which is awesome. I could definitely use this for future projects. And on top of that, this will make a really cool review because I really wanted to play around with one of these and see exactly how well they worked. And I believe this might be perfect for hobbyists just getting into electronics. Now, obviously, this isn't going to compare with a full-size oscilloscope, but this is definitely good for something you can fit in your pocket and just pull out at a moment's notice. And it's going to have an isolated ground, so if you're going to measure something, it's pretty safe to do so. I mean, the only damage you can cause is if you overload the inputs. Anyway, this guy is the digital storage oscilloscope, the DS212. I believe this is a relatively new version. There are a couple different iterations of these, and they cost different amounts. As I said, this is about, I think, $100-ish. There's two inputs, and I believe the analog bandwidth is something like, what was it, like a megahertz or something like that. So this isn't going to replace your full desktop oscilloscope, but definitely not horrible either. So we have a micro USB lead and a beautiful little package here. So let's see. Yeah, I'm gonna have to cut this open. Come on. Just don't want to get my finger. And here we go. Beautiful. So this is actually very reminiscent of a smartphone. And so we have our channel A, channel B, and these are, I believe they're standard connector. I forget exactly what they're called, but you basically have to get an adapter if you want to use a full-size connector for oscilloscope, like a BNC. And here we have an output. This actually does waveform generation, so it does like square wave, triangle wave, sine wave. Here on top we have a play pause button, and basically there is a manual, I believe, that will define what all these buttons actually do. Okay, so basically we have our play pause button here. Move that out of the way so it focuses on what I want it to focus. So this will start and stop the triggering, basically, whether it runs continuous or not. There's an on-off slide switch. There's rotary encoders that also push in. Not sure how long these are going to last because you're using these for the majority of scrolling through the menus and making the changes. So we'll see how long these rotary encoders last. There's a micro USB input. It'll charge just off of any phone charger. And the back, which is just an aluminum plate. We're going to have to pop this open. I mean, how could you not? They're just 4 Allen key screws there. So I kind of have to open these. Anyway, there's some specifications. Plus minus 40 volts, peak to peak max on the 2 A and B input channels. That's okay. I'm probably going to end up using an adapter with a 110 times oscilloscope probe, so I'll be able to measure up to 400 theoretically. But I personally don't really measure anything that much higher than 100, so it should be fine with a 110 times switch. So anyway, yeah, this is open source, I believe, to an extent. The hardware design, I believe, isn't publicly released, but I believe I did find the software, like the firmware. There was some source code available, so you can modify settings and whatnot. So it is partially open source, I would say, but would like to see the hardware schematics for kind of more in-depth mods and whatnot. Yeah, this is a beautiful. It feels really hefty and weighty. So I've delayed long enough. Let's just turn it on. Beautiful. That was quick. Holy crap. I was not expecting that. It does come fully charged. Awesome. You'd think this would be touchscreen, but no, you have to use the knobs here. And one unfortunately thing that I read is it does not remember your settings if you turn it off and then turn it back on. But anyway, I believe... okay. Yeah, so you can pretty much... So let's turn this off for now and see what else is included in this lovely box. I love this art. This is awesome. So we have a little manual, sort of safety instructions. Okay, I see. And I don't read Chinese, so the English side. Yeah, it just has basic information. Firmware upgrades are easy. Apparently I think you press and hold the button while you turn it on, you plug it into a computer, and you just drop the hex or, the hex or bin file, whatever, the firmware right onto the drive that pops up, and once it's done, it changes the extension to .rdy, which means it successfully flashed the firmware, so that should be pretty easy. There's a built-in bootloader, I guess, and just definitions on what everything does, which I just yabbed on about for the past 5 minutes. And on top of that, we get an Allen key to open it. So we can do a teardown right now, actually. They provided the tool to actually open it up. We have these little spring terminal, little grippy plugs, which will be awesome. And that connector that just plugs right in the side there. I'm not sure how many insertions and removals these are rated for, so that'll be interesting to see what goes first, the plug or the jack. These are actually really nice boxes too, or bags. They're like nice thick plastic. I can actually keep them. And here we have the actual probe itself, ground lead, and an actual full-size probe looking thing. And we have extra tips and stuff like that. So that looks pretty cool. And everything's nicely labeled here how to assemble it. So yeah, I'm gonna actually use this for a little while and maybe show you guys me debugging an embedded system and show you guys exactly what this can do in an actual use case scenario. So I'll be back in a sec. Okay, so here's that that clock that I had designed using the Numitron displays, or well, whatever they call them, the incandescent Minitron displays. And so here you can see I have it clipped to the ground of the real-time clock supercap because it's common to everything. So I can then probe using the probe end, the little pogo pin. So I should be able to just stick this and grab a signal. So right now this is the 32 kilohertz RTC, and so if I just go ahead, grab here, and then press the play pause button, that'll stop it so I can analyze it. So here it's saying it's 33 kilohertz, so it's obviously rounding. The algorithm isn't exact, but yeah, that's supposed to be 32.768 kilohertz, I believe. So that's actually pretty good enough to see that the real-time clock is running and that it's working. So then if we just go in here and go into the menu, page 1, and single shot it. So if I go into trigger and I select that, I change it from auto over to single. There we go. Then basically I can set a threshold value, and you can see the trigger goes up and down now. So if this is I can set it about here, that should be fine. And I can go up, change the scaling to about 2 volts a box, and you can even go in. I'm not going to use channel B, so I'll just turn that off. So that'll hide the trace for that, and it says single, so it's waiting for the trigger condition to be met before it'll go into stop mode once it captures something. So right now there's nothing up on the screen, and I'm just gonna go in here, and we're at 5 microseconds right now. So I'm gonna see if I can capture something. So this is I believe it's either the clock or the data line. So if I just click this, There you can see it captured a signal, and that's actually the serial data, either the clock or the actual data itself, being sent to the shift registers that control the display. So here we can see, we can zoom into the signal. We can zoom a bit out, and if we want to, we can actually go through X window. This post variable will allow you to scroll left and right, and so we can actually see more of the signal. Or we can look at the memory depth. We can change that from 4K to 8K, so we can capture more data at less resolution, or vice versa. And obviously enable, we can turn basically this scrolling mode off. So yeah, we can just go in there and make that disappear. And so yeah, you can see we can actually measure pretty much anything. The kind of limitation of this I can see so far, it is a pain to scroll through if there's a very complex signal that's a couple frames long, like a serial stream would be, will kind of get to be a bit of a pain. And we can just kind of try to trigger this again. And you can see here, if we zoom all the way out to get more detail, the limitation is sort of when we zoom back in, you can see you lose a lot of that detail because it has a finite memory depth, and in addition to that, there's a limitation in terms of the bandwidth of the scope. So you can see here, the serial data is about 20 kilohertz that I'm generating, and you can see here that it's just barely able to keep up. But if you were able to, if I had two probes, I would actually hook the second channel up to the clock, so you can see clock and data at the same time, and you could theoretically, well, manually decode the serial stream by hand if you're reverse engineering something. The thing that would make this great, and I'm sure someone's working on it, or even I'll take a look at the source code once I get my hands on it, but if you could add a like an I2C or SPI decoder. But anyway, I think that if you had some sort of very simple like UART serial decoding, a decoder built in, that would be really cool, because I could just plop this on a serial pin, and then if it could tell me what the packets of data are, that would be awesome. I have a logic analyzer to do that, but I need a full-blown computer to run that, and this is just a lot more convenient because of size. So yeah, we're just gonna sit here and put this back into auto trigger, put this into run, and get out of this menu. And we can hide the side menu by pressing and holding the button here, the S button, and take this off without destroying it. And if I look at the square wave output that I have here, I can actually just touch this to out. And if the menu is hidden, you can actually, there's a red highlight on, that is really hard to see. There's a red highlight on channel A, and we can actually change the scaling now. So I can set to 2 volts. Obviously it says channel B is hidden, and channel C is hidden. But we can see here, if I use this wheel, I can actually control outside of the menu very easily, much easier than going through the menu. Control the time scale. So here I can just grab the serial signal and zoom right in, and you can see, sorry, not serial, the square wave output of the function gen feature, and we can just capture that. I can pause, and then now here we can see that it's outputting approximately 10 kilohertz. And yeah, so we're able to do all these measurements. If you go into the menu, and page 2 will tell you, even more information if you want to calculate duty, RMS, whatever you want. And so, actually this duty for some reason is on channel B. Put it on channel A, and you can see it's 51%. So, yep, that looks right. And you can calculate RMS, averages, pretty much everything. And this guy will tell you how much the internal battery voltage is. You can see the battery says it's full, and it's 4.07. So yeah, these are definitely handy to have at a quick reference. I found out there is one thing, I've seen people complaining online about the fact that when you switch the scope off, it'll forget all your settings. So you can actually, if you change, the divisions and the scalings and all, you're going to actually go into File Manage and Save Parameters. And this will pop up, File Read Write, okay, and then it'll go away. And then when I turn off and turn on again, it should remember all my settings. Yeah, you can see what I've hidden is still hidden. So it is possible to save your settings if you go in and manually save it to the file. Now, if we want to change that square wave here, we can easily go in here and change it from a square to a sine wave at 10 kilohertz as well. Or or we can change it to triangle, sawtooth, whatever we want. So I'll just leave it on sine there. And additionally, we can actually change system settings as well. The volume is a beeper volume. I turned it off because it's annoying, quite frankly. Backlight, you can change the brightness, standby time, power off, menu cycle, I guess whether it'll go wrap around or not, item cycle, etc., post cycle. And you can actually, I'm not going to do this, but you can calibrate everything. This should have been calibrated out of the factory, so I'm not going to mess with those settings. And you can see product info and about. So yeah, you can see it uses an STM32 32-bit processor, 8 megs internal, and you can see the bootloader DFU is version 3.6, etc. So yeah, pretty cool. What's in about? About is the website of the manufacturers. Awesome. So yeah, this is really cool. I gotta say, it is limited but for the price and the size and the convenience factor, I think this is definitely something you should have. If you have the extra money to spend for a portable scope, have this in your toolbox just for emergencies pretty much and for convenience factor. But definitely this doesn't replace a full-size oscilloscope, and I do not claim that it does. But just for debugging very simple problems where you need something a bit more than a multimeter but a bit less than a full-blown scope, this is definitely really cool. I would like to see the upper range model has 4 channels and it has logic analyzation functions. I would love to see something like that embedded into this. That would be really cool. Just a portable, dedicated logic analyzer would be awesome. As I said, this is fully reprogrammable. The firmware, you can actually modify it. The firmware is available openly online. So theoretically, it should be easy enough actually to go in here and modify, add an extra mode to add some kind of logic functionality or serial protocol analyzer, something like that. Anyway, this is really cool, and I'd like to thank Banggood for sending this in for me to review, and I will definitely be using this on future projects like this little guy. Now I do have, if I bring the camera over here, you can see right here is a really old, really crusty oscilloscope, and it is functional, but the problem is it's just so inconvenient. The thing weighs a ton. It takes up half your desk, and it's just, yeah, it's a fully analog scope, no digital functions. So having something like this in addition to that will definitely be helpful, and I will be using this in future projects. So, okay, one cool thing that I forgot to mention actually, if you turn on the guy and plug it into a computer's USB port, you can actually, it'll pop up as a 8 gigabyte thumb drive pretty much, and here you can access the settings and whatnot. And also you can take screenshots. So if you press and hold while in operation the play pause button, if you press and hold it until it beeps, it'll actually take a screenshot that then you can upload or do whatever you want with. So yeah, that's pretty cool. Okay, and one last thing, we shall use the included Allen key, hex wrench, whatever you want to call it, to open this guy and see exactly what inside is ticking. This is all aluminum, very nicely made. It's date coded, I guess 29th week of 2017. So wow, this is pretty new. Very nice. And we have the battery here, which very nicely isn't glued down, so I could easily replace that. And yeah, version 1.6 of the PCB. There's a couple more screws, and not gonna poke with something metal, gonna use my finger. These are the input jacks, obviously. They're pretty beefy. They're soldered down on the other side, and it appears that there's some calibration pots here. Not gonna touch those. Actually, they look like trimmer caps. And then we have some input filtering, 2 sets, I'm guessing, basically for input side protection, some other passives, and then some SOT 23-5s in there. Probably some more, maybe some diode protection or something like that. Anyway, there is a nice little connector in here, and then the LCD ribbon just goes right in there. Let's see if I can carefully lift that out. Yep, there's pretty much nothing on this side. Do I want to take this apart anymore? Fine. We're just gonna pull this battery. Don't want to screw up the PCB. Oh, you can actually slide it a little bit, and that'll clear these jacks. Ah, that is ingenious. I like that. So yeah, you can pull this out, and I'm just gonna try to wiggle this, and it is free. Not gonna undo the cable. Just gonna show you guys just by flipping it over. You can see the rotary encoders here with the push. These are probably going to be honestly the weakest link. These rotary encoders, because they're mechanical, they're tiny, they're surface mount. If they do fail, what I will probably likely do is just solder wires and mechanical switches or something, interface it with a micro so I could use regular push buttons. There's the little speaker right in there. There's some charging circuitry in there, the LED, the charging indicator LED. There's the power input. That's a bit how you doing. I'm not gonna lie, the through-hole Molex socket kind of utilized as a semi-surface mount. That's sort of eh. There's some WinBond flash. I think, yep, that is WinBond. That is a serial flash chip. That's probably the 8 megabyte memory for the screenshots, and everything is saved to that. Here's the ARM processor. It's an STM32F303. There is a bit of this tape here, which is like shielding tape, and it's basically used to ground these two connectors. So yeah, sort of kind of could guess that this is a common ground input, and maybe there's going to be something else underneath there. Nah, actually, no, there isn't. Here's a tuning fork crystal, basically. Guessing that's probably the only crystal in the circuit, so that's probably going to be for the main clock IC. Here's another button for the trigger. There's a small slide switch here, and some miscellaneous circuitry in here, I'm guessing for the function gen output, probably like an output op amp or something like that. But yeah, there's really not that much in here, so we are just going to very carefully put this guy in, making sure this switch is in the right position so I don't break it off like I have done in the past on certain devices. This is a bit fiddly. I would not advise taking this apart unless if you're really inclined. See if it'll still turn on, and it still does, so awesome. Did not break it. All the buttons seem to work. Actually, there's only like one button. Yeah, okay. And we're just gonna close this guy back up. So yeah, so this is all just about back together. Still turns on, and we are good to go. Beautiful. So anyway, yeah, hopefully you guys enjoyed the video, and I've rambled on for a very long time. If you have any questions, put them down below. I'll do my best to answer or link to a relevant site or whatever. And I will definitely take a look at the source code for this guy and see if I can maybe add some features I'm not sure how much program flash is available on the STM32, but if there's enough, I would like to add maybe some rudimentary like UART decoder or I2C decoder, something like that. That would be really cool. And anyway, hopefully you guys enjoyed the video, and I will see you guys next time. Bye.